go ahead and go get started. Today, we're doing arithmetic sequences, chapter 9, section 2. Should say 126, but that's okay. Anyway, arithmetic sequences are strings of numbers that have a common difference. Not everything has to be arithmetic or geometric, but there's our definition for arithmetic. If you can subtract terms that are next to each other and get what's called a common difference, D, then it's called an arithmetic sequence. If one number is off or out of line, then the whole thing is out and it's not an arithmetic sequence. So, D is known as the common difference. N is the number of terms you're on. So if you subtract two terms that are next to each other, they should have what's called the common difference. Alright? So there's a theorem for sequence, for an equation, for finding any term of the sequence. That is, any nth term can be found by taking the first term, adding the common difference, and multiplying by n minus 1. That should make sense. I mean, if you're always adding 3 to the next term, if you want to find the 28th term, you're going to take the first term and add 27 times 3, and that's going to give you your answer. So it's not as difficult as you might think. In fact, this is the easiest lesson you've had this week. So all we got to do is get through it, a few equations, a few examples, and you'll be in good shape. All right? So, we'll move on. Here's an example of an arithmetic sequence. Notice if you take 13 minus 8, you get 5. 8 minus 13, you get 5. 28 minus 23, and you get 5. You always get 5. So, on that count, it's saying what is the nth term? If I put the number, say, let's see, 1, 2, 3, 4, 5. If I put 6 in the equation, I should got 33. Because 33 is my sixth term, so n would equal 6. So, to find the nth term, you're going to use the equation, and you already know the first term is 8. The common difference is 5. So you're going to take those two pieces of information. The first term is 8. The common difference is 5. You're going to take those and put them into the equation. So, you're going to have a sub n equals 8 plus 5 times n minus 1. You got to simplify it. If you don't simplify it, you're going to lose points for being lazy. So, you simplify it, distribute the 5, combine like terms, you get 3 plus 5n. Now if you put in 6, you do get 33. If you put in 5, you get 28. If you put in 4, you get 23. You put in 3, you get 18. 2, you get 13, and 1, you get 8. So on and so forth. So that's how it works. You just got to know your equation. And you got to remember this is going to be on your final. So, you got to remember it. And it's not that difficult to remember. In fact, it's pretty easy. Okay? Fantastic. Let's try another one. Find the nth term, 5th term, and 10th term of the arithmetic sequence. Well, the nth term, first of all, is it arithmetic? Yes, it is. The common difference can be positive or it can be negative. In this case, it's negative. So, you take the common difference, and you take the first term, which is going to be 16 and negative 3. You're going to put it into your nth term equation, and you're going to work it out. So, put in 16, put in negative 3, you'll work it out and see what happens. And this will give you your nth term. And it doesn't take a rocket scientist to solve this. Hopefully I didn't make a mistake when I said that. You get 19 minus 3. And just a quick check, you put in 1 for n, you get 16. Put in 2, you get 13. 3, you get 10. 4, you get 7. So it works. So that takes care of the first one. Now for the fifth term, you're just going to put in 5 for n. Oh, didn't do that. You're going to put in 5 for n, and you'll get out, I don't know, the fifth term will be, subtract 3, 4. And then the 10th term will be negative 11. Okay? So, let's see if this works. I'll try it. Hey, this isn't too bad. A sub 5 equals, pretty funny actually. A sub 5 equals 4. And A sub 10, nice, equals, let's see, no, not negative 11, 33, 19, 14, that sound right? 19 minus 30 is, yeah, it is negative 11. Fantastic. Negative 11. All right, good. Whew, glad I got that worked out. All right. On this one, it says find the specified term of the arithmetic sequence that has 2 given terms. Suppose you're looking for the 10th term, and the second term is 1, and the 18th term is 49. There's lots of ways of doing this. I just put in the equation and solve it pretty quick. I don't like to waste time trying this, trying that. You know, some people take 49 minus 1 and get 48. They're 16 apart. Therefore, the difference is 3. You know, you can do that. Or you can just set up 2 equations. If the 18th term is 49, well, that means that you have 49 equals A1 17D. It is 18. On the next one, if you know you're going to have 1 equals A sub 1 plus 1D, you can subtract the equations. And when you do that, you end up, like I said, with D equals 3. Well, if D equals 3, that means your first term is going to be negative 2. And if your first term is negative 2, you can generate an equation and you can come up with your own solution for the 10th term. That's how it works. Well, yeah, there's lots of ways of doing it. This is just one way. This way is probably more universal than any other way. So, you take that, put in the equation. The first term is negative 2. The difference is 3. You're looking for the 10th term, so you take 10 minus 1. Do your arithmetic, and you get 25. Congratulations to all those that got that right ahead of me. And congratulations to all those that wrote it down, and you can give it a shot. That's a very easy test question, so you should be able to get it right next week on your test. Okay, we are moving on. Time to move on. Here are 2 partial sum equations. Now, before you go writing this down, let me just share with you one thing. This first one comes from Gauss, the counting principle. If you have the numbers 1 to 100, 2, oh, this is bad, 3, 4, oh, this is bad. I don't have my pen, as you can tell. For all the way up to 100, you know, if you had 97, 98, 98, 99. If you add up all these numbers 1 to 100, you can see that, oh, that's bad. There you go. You can see that if you had the first one and the last one, you get 101. That's what this says, this equation right here. If you had the first one and the last one, you get 101. Well, if you do that with 2 and 99, you get 101. 3 and 98, you get 101. 4 and 97, you get 101. How many pairs would be like that? Well, yeah, it'd be 50. So if you take 1 plus 100, That gives you 101. There's going to be 50 pairs like that, so you take that times 50. And if you take a look, oops, that didn't go so well. If you take a look, n is going to be 100. 100 divided by 2 is going to be 50. So that's where the equation comes from. When you add something that's arithmetic, you're always going to get the same sum with the first and last, the next first, and the next to last, and so on and so forth. You just add up how many pairs that is. Down here in this equation, again, this isn't very difficult. That's part of our nth term. In fact, if I take one of these away and put it right here, a sub 1 plus d times n minus 1, that is my nth general term. That's where it comes from. The first and the last. Then you just put in place of this a sub n. Oops, sorry, that was bad. Then just put in a sub 1 plus d times n minus 1. You gotta know what you're writing down, and you gotta know why you're writing it down. So there's the answer. I mean, it's the same thing. It's just written a different way. Depending on the question, but you shouldn't memorize it. You should know those things. Okay? Well, it's time to move on. That was interesting. I like that. I like using the pen, but I like the information. So, the sum. Find the sum of those n terms for the first 40 terms. If the first term is 5 and the common difference is a tenth. Well, if I use that squatty little equation and I want to find the last term, if I look for the 40th term, I know I got 5 plus the common difference times 40 minus 1. You're saying, what's that do with anything? Well, for one thing, these little animations are out of order, so I'm trying to wing it. And for another thing, I'm looking for the last term so I can put it in my equation. See, if I just use that equation, I don't know what the nth term is. So I have to figure it out before I can use this. I know there's going to be 20 pairs. I just don't know what to add the 5 with. If I can add the 5 to something, I'm in good shape. So 8.9 comes over here. Now I have everything. I got my first term, my last term, 13.9. There's going to be 20 pairs of those. You end up with 278. Pretty slick if you think about it. That's the whole idea, is just thinking about it. Understanding what you're doing, why you're doing it, and moving on with it. Okay? So, next. Let's try another one. Evaluate the following sums. How many of you remember on your own how to do this using the sum sequence? If it's a skill you picked up in class the other day, great. If you don't have the hang of it, it's probably time to. Oh, sure, you could use the equation we just used, but I got a feeling that 95% of kids are going to be using the sum sequence 4x plus 3, x, 1, and 5. I mean, come on, it's not that difficult. It should be pretty easy. And if you can get knocked out that quickly, you're not going to make any mistake with your arithmetic, you should have got the answer 75. All right. Try another one, see if you get the hang of it. 6i plus 2, I equals 1 to 112. I just do the same thing. I'll give you a minute, see if you can punch it out and get it right. All right, you got it? Yep, that's why I would do sum sequence, 6x plus 2, x, 1 to 112, and I got 38,192. Hopefully that's what you got. If not, we'll talk about it when I get back. I should be back possibly Thursday afternoon, maybe Friday. All right. Oh, we're almost done. The last thing, well, not the last thing, is when you have to give a sequence or a series and you have to put it in sigma notation. There's 3 things you have to do. I always do 1 automatically. You have to write sigma. I usually try to start with n equals 1 if I can. Now there's two things left for me to do. One, find the nth general term. And two, find out how many terms there are. Once I find out those things, I'm done. Nth general term is pretty easy. You just put in the information, 3, and the difference, n minus 1. You work it out, and there's your nth general term that you can put into your summation. 5n minus 2. Now, if I can just find what term 463 is, I can put that number of terms in my sigma notation for summation. So, anybody got ideas? Yeah, that's what I was afraid of. All right, so take 463 equals 5n minus 2, add the 2, divide by 5, you're on your way. So you're going to have 93 terms, 5n minus 2, and then to find the sum, I didn't do this earlier, but I'll do the sum sequence program. Well, actually, no, I'll take 3 plus 463, 3 plus 463, that's 466, and there's going to be 93 divided by 2, 93 divided by 2, 46 and a half of those pairs times 466 gives me 21,669. So I sum, the sum is 21,669. That's what I got. 669. I just add the 3 and the 463 together, and then I took 93 and divided by 2. So I took 3 plus 463. Oh, this is terrible. This is just terrible. 93 divided by 2. Oh, this is bad. There we go. All right, you got the idea. Very good. Try this one. Find the number of terms in the arithmetic sequence with the given conditions. If the first term is -1, the common difference is 1/5, and the sequence has a sum of 105. What's strange or what's missing about this one? Yeah, you don't know what n is. That's what it's asking you for. Find the number of terms. Okay? So I need an equation to find out what n would be. There's that one long partial sum equation. It looks long, but it's actually not too difficult. So I would just put my numbers in there. You might not remember this for the test, but if you don't, you can use the partial sum equation, and then, figure out what n is from that. So I put in my common difference, my first term. As you can see, I got nothing but n's left. So I can start simplifying. -2, 1/5 n minus 1/5. Combine inside, you get -11/5, 1/5 n. I'll let you write this down because I'm getting ready to leave the page. All right. So we left off right here. 42, -11/5 plus 1/5 n. Distribute the n, and you get n and n squareds. Looking like a quadratic, and it is. Good thing you got your quadratic program. Unless you're Nagy. Well, he had to take his off, so I'll have to put his back in when I get back. And I got 21 and -10. But since we're talking about sequences, and you can only put in positive integers, that means the only answer is going to be 21. Okay? Yeah, and that was a little bit difficult. That's one of the higher end problems. Is it going to be all like that on your test? Yeah, probably. So, anyway, you have the rest of the hour to work on this. Who's ever in my place, if they don't work on it, change it to all, have it due for them all, and I'll collect it and we'll give it a grade. All right? You should have plenty of time to get started. I mean, it's not that difficult using your calculator and things like that. Just keep it quiet, get to work, and hopefully you won't get your assignment extended. All right? Thank you. Have a nice day. And I'm going to sign off as soon as I get off this screen. I'm going to discard those. I'm going to shut this off. All right, thanks again. Have a nice day.